Hi friends, today topic is Bernoulli's theorem, right? Before going into Bernoulli's theorem, see some physical phenomena in real time. When the passenger near to the high-speed train, the passenger pulled into the track, right? That's why we listen announcement in railway station that is, please stay away from the yellow line, right? Or near to the high-speed trains. Because the pressure between passenger and the train drops or decreases due to high speed wind is flowing between passenger and train. Same way, when we blow air on top of the tube which is filled with ping pong balls, these ping pong balls coming out of the tube because the pressure at the top of tube decreases. And in cyclones, when high-speed wind is blowing on roof of the building, the thrust force developed, right? That's why in cyclones or tufans, majority of airport railway station roofs are damaged, right? And the same way, when high-speed wind is flowing on top of the wing of aeroplane, there is a thrust force developed on the aeroplane. These all phenomena can be explained by simple equation, that is Bernoulli's equation, right? That is Bernoulli's equation, right? For this Bernoulli's equation, we need continuous pipe. The non-viscous fluid is passing in the tube, right? This non-viscous means friction is zero, right? The fluid is passing by using pump, right? This is pump. Now simple analysis, that is work done by this pump is equal to change in velocity of the fluid and changing height of the fluid, that is energy stored in the form of potential energy, right? ఈ పంపు ఎంత ఎలక్ట్రికల్ ఎనర్జీని కన్జ్యూమ్ చేసిందో ఆ ఎనర్జీ మస్ట్ బి converted into kinetic energy, that is change in velocity of the fluid and stored in the form of potential energy, right? That is work done is equal to change in kinetic energy plus change in potential energy, right? The work done by this pipe is, right, work done by this pipe is simply F into S. This is a mechanical work done. We should not use force here because force is unidirection, but in fluids the direction is in all direction. Force acting on liquid in all directions. So we should not use force here. That's why we should use pressure. So pressure is equal to force by area, right? So force is equal to pressure into area. Work done is equal to pressure into area into S, right? Here, work done, energy consumed by this pipe at this point is P1 and height is H1, area of cross section is A1, right? And velocity is V1, right? So, pressure at this point is P1 A1 into S1, right? Due to this force, the fluid traveling at a distance S1, right? We know A into S is equal to volume, right? And here the work done is P2 A2 S2. This is acting on reverse direction because when the pump is forcing liquid in this direction, By Newton's law, this pressure is acting in opposite direction. So net work done is equal to P1 A1 S1 minus P2 A2 S2, right? A1 S1 is equal to B1. A2 S2 is equal to V2. We know in continuous pipe, that is no leakage or no external connection to flow the liquid, then V1 is equal to V2 because that is change in volume, right? V1 is delta change in volume is equal to change in volume at the second point. So because in continuous pipe the liquid flowing per second is equal at any point. That's why P1 minus P2 into delta V. This is work done by the pipe from here to here. From point 1 to point 2, the work done by this pump is P1 minus P2 into delta V. Now, see kinetic energy, change in kinetic energy is equal to half delta M V2 square minus V1 square, right? Because I am focusing on these points only, right? The work done, I am focusing on work done from one point to second point, right? From first point to second point throughout the pipe of MV square, right? That is, we know that. But from one point to second point, the work done is of delta M. That is change in mass of the fluid into V2 square minus V2 V1 square. If I place here M, then I consider whole mass of fluid. But my my interest is from point 1 to point. That is M is equal to rho into V. Here M is equal to delta M is equal to rho into delta V, right? So of rho delta V into V2 square minus V1 square. This is change in kinetic energy, right? Same way, change in potential energy, right? Change in potential energy is equal to delta M G H, right? H2 minus H1. So delta M is rho delta V G H2 minus H1, right? From law of conservation of energy, P1 minus P2 into delta V work done by the pump is should equal to change in kinetic energy of rho delta V V2 square minus V1 square plus rho delta V G H2 minus H1, right? Delta V cancel on each side. P1 minus P2 is equal to half rho V2 square minus V1 square plus rho GH2 minus H1. So all same terms are taking on one side. P1 plus half rho V1 square plus rho GH1 is equal to P2 plus half rho V2 square plus rho G. From the above equation, P1 plus half rho V1 square plus rho GH is equal to constant, right? Now observe, if height is constant, right? Let's say uh, height is constant, then P1 plus half rho V1 square is equal to P2 plus half rho V2 square. Same way, if velocity is constant, P1 plus rho gh is constant. Pressure is constant, half rho v square plus rho gh is constant. These are the derivations from Bernoulli's equation. Now see physical phenomena, how those things have happened. When high speed wind is flowing here, right? High speed wind is flowing here. Height is same, right? From train and passenger height is same. So P1 plus rho GH is constant of rho V square. V1 square is equal to P2 plus of rho V2 square, right? P1 minus P2 is equal to half rho V2 square minus V1 square. Now consider velocity of the wind behind the passenger is 0, right? If we consider velocity of the wind behind the 0, then P1 minus P2 is equal to half rho V2 square, right? అంటే passenger వెనకాల velocity of the air is 0. Passenger ముందు velocity of the air is same as velocity of the train. So pressure difference is developed on the passenger, right? P1 అంటే behind the passenger. Here pressure is P1. Between the pressure is P2. Now P1 minus P2 is half rho into V2 square, that is velocity of the train square, right? If the train is passing 100 meters per second, now half rho V2 square, that is 100 square. Rho is density of the air is 1.2, let's say. This much pressure difference is applied on the passenger. Let's say surface area of the passenger is 0.5 meter square into half rho, that is 1.2 into 100 square. This much of force is applied from back side of the passenger. That's why there is a pulling force towards the train, right? Same way, when high speed wind is flowing here, here the pressure is dropped, right? Here this is P1, pressure is P1 and velocity of the wind is V1. Here pressure is P2, velocity of the wind is V2, right? Neglect the height. So P1 plus half rho V square, V1 square is equal to P2 plus half rho V2 square. From P1 minus P2 is equal to half rho V2 square minus V1 square, right? Here velocity V1 is 0. So P1 minus P2 is equal to half rho V2 square, right? Now this is positive. That means ఎప్పుడు P1 minus P2 is positive, P2 is less. అంటే P2 P1 కన్నా తక్కువైనప్పుడే ఈ P1 minus P2 పాజిటివ్ అవుతుంది. సో హియర్ ప్రెషర్ is dropped. That's why these ping pong balls coming out of the tube. Same way, velocity of the wind inside the house is 0, right? Here the velocity is V. So that's why there is a thrust force developed on the building. That's why in cyclones, where the area of cross section of the roof is high, then force is high, pressure into area high. So there is a chance of destroying roof, right? In hudud tufans or cyclones, most of the airports area of roof of airport is more than there is a more force developed on the roof. That's why there is a chance of destroying. Same way, this is the aerodynamic shape of the aeroplane. Now wind is coming. Now there is a chance of high speed wind is here, right? There is a chance of low speed wind is here because this this length is high, right? This length is high. From here to here, the pressure is same. Horizontal pressure is same. So this length is high. That's why the wind should travel more fastly in upper position of the wind. That's why where the wind is flowing high speed, then there is a pressure drop. That's why the aeroplane lift off, right? ఎక్కడైతే మనకి హై స్పీడ్ ఫ్లూయిడ్ అనేది పాస్ అవుతుందో ఆ హై స్పీడ్ దగ్గర ప్రెజర్ అనేది డ్రాప్ అయిపోతుంది, రైట్? నౌ సీ సమ్ numericals, interesting numericals by using Bernoulli equation, right? Calculate the minimum pressure required to force the blood from heart to top of the head. That is, vertical distance is 0.5 meter. Assuming the density of the fluid is blood is 1020, 1040, right? Now, velocity, consider velocity of the blood is constant everywhere. ఈ వెలాసిటీ కాన్స్టెంట్ అవ్వాలంటే ఏం అవ్వాలి? ఏరియా ఆఫ్ క్రాస్ సెక్షన్ ఆఫ్ వెయిన్స్ నరాల తాలూకా క్రాస్ సెక్షన్ అనేది సేమ్ అవ్వాలి, రైట్? దట్ ఈస్ ద అజంప్షన్. ఏరియా ఆఫ్ క్రాస్ సెక్షన్ ఆఫ్ వెయిన్స్ ఆర్ కాన్స్టెంట్, దెన్ velocity everywhere is constant. Now our Bernoulli's equation gets simpler, that is p1 plus of sorry P plus rho gh is equal to constant. So P1 minus P2 is equal to rho g H2 minus H1. Here given H2 minus H1 is equal to 0.5 meter from heart to head. Rho is equal to 1040 and g is equal to 10, right? P1 minus P2. This is the pressure, blood pressure. అంటే ఒక మనిషి కనీసం బ్రతికుండాలి. బ్లడ్ హెడ్‌కి సప్లై అవ్వాలంటే మినిమమ్ అంత బ్లడ్ ప్రెషర్ ఉండాలి, రైట్? దిస్ ఈజ్ కాలిక్యులేట్ చేద్దాం. 1040 ఇంటూ 10 ఇంటూ 0.5, దట్ ఈజ్ 5200 Newton per meter square. That is the pressure, right? If we want pressure in Hg, that is 1 Hg is equal to 133 pascals, right? Now 5200 by 133, that is 39.1, 39.1 Hg, right? We neglect viscosity, friction here, right? So minimum pressure to alive the person, that is 40 Hg, right? If we consider viscosity, that is 40 H. 1 H, 1 Hg is missing due to this viscosity of the blood, right? Do some another example. Here, velocity of the wind in Hudud Tufan, wind speed is 215 meter per second. The building area, roof area is 50 meter square, right? Find the force experienced by the roof. If we neglect the thickness of the roof, H2 minus H1 is neglected, right? Approximately 0, right? Now our Bernoulli's equation P1 plus rho g of rho v square V1 square is equal to P2 plus of rho v2 square, right? Now p1 minus p2 is equal to of rho v2 square minus v1 square, right? This is our new equation, right? Now p1 minus p2, this is the building, right? Inside the inside the building velocity is 0, right? So half rho density of the air is, let's say, 1.2 into v2 square minus inside the velocity 0, that's why v1 is 0, half rho v square, that is 5215 square, right? That's why now calculate 0.5 into 1.2 into 215 into 215, that is 27735. This much of pressure Pascal pressure is developed on the roof. If we want force into area, that is 50, that is 1386750, 13 lakhs 86 thousands of newtons pressure is developed on the roof, right? That's why roofs are damaged, right? At the time of tufans. How we reduce the damage at the time of tufans? Let's say this is the building. Here velocity of the wind is 215 meter per second. If we develop velocity of the wind inside the building, now v2 minus v1 square is dropped. That's why ఆపోజిట్ సైడ్స్ ఉన్న విండోస్ మనం ఓపెన్ చేస్తే రూఫ్ మీద ఎంత వెలాసిటీతో విండ్ ఫ్లో అవుద్దో సేమ్ వెలాసిటీతో ఇన్సైడ్ ద బిల్డింగ్ ఫ్లో అయితే అప్పుడు దిస్ ఫోర్స్ డెవలప్డ్ ఈజ్ reduced, right? Minimum force is developed on the roof. That's why we should open opposite sides of the windows. But another damage is due to high speed wind in the building, equipment is damaged, right? అంటే ఎప్పుడైతే మన ఇంట్లో హై స్పీడ్ అవుతుందో రూఫ్ సేఫ్ గా ఉంటది కానీ ఇంట్లో ఉండే వస్తువులు అనేవి డ్యామేజ్ అయిపోతాయి. థ్యాంక్ యూ ఫ్రెండ్స్. నెక్స్ట్ మనం ఇంకా ఇంట్రెస్టింగ్ టాపిక్ తో కలుద్దాం. థ్యాంక్ యూ.